In the last video, I came into my system, started to get the PSOC connected. I connected the multiplexers for frame 1's VRAM, and then I connected the transceivers to get that data back out to the bus. All of that coming through the ISA bus into my 286 system. One thing that I'll maybe comment on right away, at that video I was running the same oscillator I'm running now, which is the 32 megahertz. But I had dropped the clock speed down in a quarter, so I was actually running 4 megahertz bus with a 2 megahertz processor clock. In this video, I am back to full speed. I've got still with this 32 megahertz. I'm bringing 16 into the board and 8 megahertz at the processor, which means I'm running 16 megahertz through all of this. And you're going to see that so far that is working. And what it came down to is this clock coming out of the clock generator. I had an inline 100 ohm resistor, and that resistor was working well for just this board. But as soon as I tapped in some additions I made, these registers over here, I had to use the clock, and as soon as I touched that clock, this would quit working. So I changed that resistor. I dropped it down to a 22 ohm from a 100 ohm. That resolved the issue here and allowed me to go back up to full speed, which is great. So I thought that was kind of a nice little note that this little resistor here makes a pretty significant difference depending on the load that I have. On the screen is the schematic, and last time I walked through that kind of in a visual way and pointed out maybe some of the things that I've been working on. And again, the things that I worked on last time would have been to come in here and get these 4 multiplexers connected into the addressing, get this additional multiplexer added that was and is still for now connected to ground, but that'll eventually connect to my register. And that brings in addresses from my system into the VRAM. And then this is my VRAM right here, so it brings that addressing over into the VRAM. And then out of the VRAM, or in the VRAM, either way, the data side of it is going through a pair of transceivers, which are these transceivers right here. And that was all working fine. And I said in the last video, my next steps are to get a couple of things up and running. One is the registers, and then one is the frame 1, the other frame of memory. I decided to start with just doing this video on just the register up here. Just to kind of walk through that, since there's actually quite a bit that had to happen for that to work, a lot of wiring at least. And in an upcoming video, then I'll proceed with frame 1. And then the video after that will start to get me into the video output using this video memory. So a couple things I'll point out over here. Really, this has not been touched on the 286 side other than a couple of things. Again, this resistor, I changed the value of it. And I also did put back in the routines to test, I'm testing RAM on boot, I'm testing the first 64K of VRAM, and then I added a test to actually test the register over here. Can I write a value to the register of the VGA circuit and read it back? And then I did put in the code to, again, reuse or reinitialize this little display, because as it's doing the RAM, it's doing a countdown, and that's a nice indicator to me that it's working on that and not stuck somewhere. So I found that helpful. And again, changing this resistor, all of that seems to be working fine. Now, for me to come into my registers on the screen here, let me just jump down to this section where I show the registers. What I have is I have 4 of these 74 173s. So that's these 4 right here. And I have to bring into that the data from the ISA bus, and so that I can read in a value at any point. And then I store it in that register and I output it through these 16 pins across those 4. So I have to bring in that, and then I have to be able to output, and that output will go to transceivers that I can decide when I want to put it back onto the data bus that goes back to the ISA. So it's a one-way pull, and then if I want to put it back, I have to run through these transceivers to put it back onto the data bus. I also temporarily hooked up just a pair of 8 LED bar graphs so that I can see what's in these registers when I'm testing. And for now, that is actually quite helpful. And at some point, I'll just rip this part out. This isn't a big deal, but it's helpful for me to visually see maybe which register I'm working in. And if I do find it helpful, maybe I will just run wires and get rid of these quick jumpers that I put in here for the time being. So I have my 4 173s, I have a pair of 245 transceivers, and again, the transceivers, I had to get the data, and I wasn't going to run all the way from over here for the data connector since the data was already on these transceivers for accessing this frame 0, so I just jumpered over the data lines to get that data in. Then the output, or the other side of this specific transceiver, then connects to all of my outputs on these 173s. And the data coming into the 173s is also jumpered from this same set of data lines coming over to this other set of transceivers. So data comes over, jumps, and that is giving me the circuit that you're seeing on the screen right here. And then again, I added these bar graphs just for a visual indicator. And so at this point, I'm going to go ahead and turn on the system. And it's counting down through the RAM segments as it tests those. When it gets done with that, I've got all dashes. You probably can't read the screen on the camera because I'm zoomed back quite a bit to fit all of this on the camera. But it did a RAM test pass, VGA reg test pass, and VRAM test pass. So that is all working. You can also take a look over here at the registers, and if you can pick that up, I've got 4 bits on, 4 off, 4 off, 4 on. And I'll show you the code real quick that I'm using to test that. So if I jump over to my assembly code for a second, this was updated today, so I suppose I could modify this real quick. So 14th of January. In my code though, when it initializes, when it starts up, I am skipping the VGA initialization code. That was for my old VGA card. I'm skipping the SD card initialization for now. But everything else I'm basically going through and initializing, including this little 8-digit 7-character, so 8-char 7-segment init sequence to get this display working. But in this code, one of the things I do call is post tests. So these are my power on self tests. And if I go down to that routine, these are the tests that I'm currently calling. So I'm skipping these now just for the sake of boot time, speeding things up here as I'm doing the work on the VRAM, the video card. But I do go in and test all of the RAM. Then I test a video register, and then I test the VRAM. And last time I pointed out what I was doing to test the VRAM. So with this video, I'm just going to look at this video register. And pretty simple. I just simply, first of all, I write to the little OLED screen that I'm starting that specific test. So the sequence of text I put out here, it says VGA reg test colon. And that's what's going to happen when I go ahead and call this right here. And then I move these bits into my A register, and then I move that A register out to that I/O port that is in my video circuit that basically connects to these 4 ICs right up here. And I output that, and you can see on the LED bar graph that is what I got on the output. So that is looking good. And then I pull it back in, I read it back in, and I compare it. And if it does match, that means I read from that register correctly. I jump down to the pass and say that I passed. Otherwise, I fall into this fail and I say that I failed. But it's not failing, and I can clearly see the actual values over here are coming in just fine. So that's what I've done on the assembly side of things to support all of this. I did also, to make all of this work, had to go in and update my PSOC because now there's a bit more logic. In the last video, my logic was really simple. I was just passing through some signals is all I was doing on this PSOC. Well, now this is what the logic looks like. There's a little bit more, still nothing too crazy here. The way I'm organizing this is over to the left. I'm just showing different inputs I'm bringing in. So you can see I'm now bringing in addresses 7 down to 0. That's these green wires. And then I've got to bring in whether or not I'm in the address space of the video, the 64K video space, which was that A0000 range. I'm doing that with these two chips up here, and I bring that signal down just so I know that I'm in the right range. I'm bringing in the I/O read-write and the memory read-write signals coming over from my 286 through the ISA bus for that. And I'm also bringing in BHE from the ISA bus. And obviously the addresses and all that's coming from, all this is coming from the ISA bus minus this video enable, which is pulling addresses from the address bus to make its output that goes into the PSOC. And then over to the right, you can see what I'm doing for now, whether or not I'm enabling the VGA or the 286 on frame 0. I'm just pulling this netvid enable B. So for now, all I'm checking is, am I in the right address space for the video card? And if so, I'm assuming this is the only frame available. And that's what that's doing. And then as far as am I writing or outputting, I'm just simply using these signals for the mem write, mem read. Whether or not I should be reading the low, the high, or both, I'm using the A0 and the BHE signals to enable these chips with those chip enables. And then I have all of these other signals that I'm not using, so should I be outputting this RAM or not? And right now that is all just set to high with an active low, meaning that these aren't used, and you can see nothing. I guess I did connect power, but nothing else is hooked up here. And then I put in just a little bit of logic up here that says check if I'm actually in this I/O register for up here. So am I in the right address for the register? And that is just what I'm calling the labels that invisibly are connecting these. But I'm looking at A7 needs to be a 1, A6 0, A5 1, the rest coming down are low. And if I pull up a calculator real quick, you can see if I go to hex and, well, I'll just jump to putting in, for example, A0. A0 is the I/O address that I'm using for this register. So that's not a memory mapped address, that's an I/O address that the 286 can use. And I'm using A0 for that address. And so 1010000 basically is what you see here. I don't care about the A0 because that's going to be low or high depending on if it's low byte, high byte, etc. And that's coming from a signal off my 286. So this is giving me whether or not the register should be active right now as far as the addressing is concerned. I then combine that and say, well, if I'm doing an I/O write, I'm not doing memory read or write, I'm doing an I/O write, and I'm in the correct address space for the register, then go ahead and have that register read in the values from the data bus. If it's an I/O write and I am in the active correct space, address space for the register, and A0 is low, then I also want to bring in the low value. So this is bringing in the high 8, this is bringing in the low 8, what you're seeing on the bar graph. So high or low 8 bits, or high byte, low byte for the overall word. So that's the decode logic I'm using. I'm using this I/O write. I'm using whether or not I'm in the right address space when I'm doing an I/O write. And then I'm using BHE and A0 to determine which set, the upper pair or the lower pair, am I really working with. And then whether or not I should read out the data and put it back onto the data bus going back to my 286. I'm going to check for I/O read and then check that I am in the right I/O space for this. And I don't think I need to bother with the BHE and A0. It can read all 16 bits, and the processor, if it's only asking for the lower or upper byte, will just ignore the others, is my understanding. So that's what I've done here. I've not bothered checking BHE or A0 in that specific scenario when I read, but when I write, it's important so that if I try to write a lower byte, I don't accidentally write the entire word and mess up the upper byte, if that's a scenario that I could run into. So that is the current decode logic that is sitting inside of this PSOC. So I think that's about it. I've got next steps. If I go back to my schematic for a second, I have some additional logic I need to put into this decode. First things first, I suppose I need to get this section of things connected. And if I come down here, I have this VRAM frame 1, so that's this pair of static RAMs. I have the multiplexers here, and then I have a pair of transceivers that I have ready sitting up here. And this, as far as getting the address data in, is going to be pretty easy. I'm just going to hop over from the identical pins up here. So it's just basically bring those over. Now remember, in a later video, I have to get all my addressing coming from my VGA output, and that's going to have to plug into all of these, and then I'll hop them up to here. But for now, I'm just looking at the addressing coming from my 286. So I'll get all of these lines brought over here. I'll bring all of this over to these two, just like you see up here. And these pair go to this pair of transceivers. These are now going to go to this pair of transceivers. And then I can just connect them right into these same data lines. So I'll just hop all of those over. So I shouldn't have any seriously long runs here anywhere. I'm just jumping off of things that I kind of already have pretty close and have done the hardest work. The rest of this stuff for frame 1 should be pretty easy to connect up. And the other thing I need to do is I now need to change the upper 4 bits used in the addressing to not be grounded, but to actually pull from my register. So I've got those appropriate bits up here, and I'll just pull off of that. So as I do an IO out to that register, I can dictate which 64K segment am I working with in the memory. And right now I have those 16 segments. I have this all at 0, which means it's only using the first 64K segment. But as I increment this and flip one of these on, basically I got 4 bits here. So as I go from a 0 and work my way up to 15, I can navigate through all 1 megabyte of this memory right here. And that same thing, of course, will happen when I get down here to this. Maybe one other thing I was going to comment on, just voltages. So I've got a lot of stuff here. And in the upper left, this is where all the power is coming in, is a pair of banana plugs from my power supply. And at the power supply, I am outputting 5.3 volts. So between the power supply and getting into the middle of this card, I'm down to 5.17, 5.18. I'm then running a small jumper over to this other card, and you can see by the time it gets to the middle of this card, I'm at 5.08 or 9, somewhere pretty close in there. And if I come down and measure down here, which I figured there or here are the 2 worst points of the board at this point, I'm at 5.07. So I'm barely losing anything as this circuit is under load and running. And so I'm pretty happy with that. That means I can probably actually, I might even measure this real quick. Let's just see. Right now, if I measure here, I'm at 5.0735. So what I think I'm going to do is just try to hold that, and I'm going to drop the voltage on my bench top until I get down to 5 volts here. And so now I'm at 503, 502, 501. Okay, now I'm at 5.0079 down here, 502 here, 511 here, and 5.24 on the power supply. So I think, that's all coming across. I probably should check it down here also, just to make sure there's not something down here that is more of a concern. And let's see, I think I'm just going to check it on this IC. So power ground, and there I'm at 4849. So this right now is the lowest point on this entire thing. So I probably need to bring that back up to make sure that I'm getting, I want to be high enough, I guess, to get a 5 volts down there. So let's just see if I can get that somewhat close. 4.9 at that point. And it looks like this is going to be my continued challenge area. At that point, I'm 4.96. So that's probably good enough. But that kind of takes me back to the voltages like what I was seeing before. So I just know that the voltage drop is the greatest down here. let me just do a power off and power on, make sure things still work at the voltage I now have things at. So it's counting down through my RAM testing and passed all my tests. You know, all my RTC, my real-time clock, temperature, all that stuff's working, register's working, so that all looks good. Maybe just a side note, I did actually order the updated motherboard or system board. So I do have a new board coming, should be a little bit narrower, and I doubled the size of all of my traces for VCC and ground, and then I also filled in as much copper VCC on top and copper ground on the bottom, which is really more a band around the outside than anything. But I think that's going to help with some of this voltage drop. So maybe in another few weeks, I'll replace this board with that one. If I receive it and everything, you know, builds okay on it and I don't have any issues with it. Okay, so I think that is where I'm going to stop this video. Maybe last comment I will make is next step then is I want to get this other frame fully connected. So I'll get all of that connected in, back out through the transceivers, and then I will write a little test routine that starts with the first frame, goes through all 1 meg of it, jumps to the other frame, goes through all 1 meg of it, and tests all of that. That won't be part of my normal boot process just because it will take too long, but I want to do that for now just to make sure this is all looking pretty good. And then I think the video after that, I can come back now and get my video addressing and video output working. That I'm hoping is pretty minor since I had already done that in a previous video. And all I'm doing is tap in the appropriate address lines in here, and we'll use a comparable output circuit as what I had before. If you have any feedback, things that you're seeing here that I should think about looking at differently, or have just any general comments or feedback, feel free to drop a note below on the YouTube video, or check out my blog, and I try to add some extra data up there. The latest schematic is there, and you're welcome to add comments and questions there too. So thanks for watching.